So in this lesson, we're going to look at using technology to help us with our sequences and our recursive formulas. So I want to start off with a quick review. So take a look. Here's two sequences, sequences A and B. What I would like you to do is write the recursive formula in function notation for each of these sequences. Pause the video, do the work, and then we'll come back and I will talk you through it. So for A, I'm going to start off actually, before I even dig too deep into this, and say I'm writing a recursive formula, so I need A of 1, I need A of n, and A of n is going to be something involving A of n minus 1. And I'm going to have n is greater than or equal to 2. So I can write that right off the bat. Then I look and see, now let's see if I can figure out what exactly is going on with this one. So 24, 26, 29, 32, 35, it's going up by approximately the same amount. So I'm going to assume arithmetic and see what happens. So I'm going to look for the common difference. I want to make that a little smaller. There we go. And so I'm going to take now minus previous. I'm going to say, what's the difference between two terms? 26.8 minus 24 is 2.8. And let's see if that's going on. So I try this next one. 29.6 minus 26.8. And that will be 16 is 8. 8 minus 6 is 2. 2.8 again. It looks like I have that common difference of 2.8. So my first term is 24. My common difference is 2.8. Since it's arithmetic, I have a common difference. I'm going to say here just plus 2.8. And that's my recursive formula. For B, again, I will start off and say B of 1 is, and I have that number here, let's just write it, 6144. B of n is going to be something involving B of n minus 1. And n is going to be greater than or equal to 2. Again, I can always write this when I'm doing these recursive formulas. If I look at this, 6,000, 4,000, 3,000, we're not going down by the same amount. 61 to 46, 46 to 34, those are different amounts. It's not going to be arithmetic. So I'm going to look for a ratio. So I'm going to take, again, now and previous, except this time I'm going to divide. So I'll take 4608 divided by 6144, and that will be 0.75. I'm going to try it over here. Let's go 2592 divided by 3456. I get 0.75. So it is geometric. I have a growth factor of 0.75, which means that's what I'm multiplying. 0.75 times b sub n minus 1. And there's my formulas. So again, the big push of this first part of this chapter is getting to the point where I can recognize the pattern, especially in an arithmetic or a geometric function or a sequence. So what we really are planning into, I just wanted to do a little refresher of that to start off getting us into this. What we really need to do is work with these recursive formulas. So I have this one, j of 1 equals 25, and j of n is 1.1 1.2 times j of n minus 1, where n is greater than 2. So first, find the first 5 terms for me. Again, if you want to play with that a little bit, pause the video, see what you can do, come back and see what we say. Finding the first 5 videos is not too bad, but I'm going to show you a shortcut that you can do with your calculator. So let me bring up a calculator here. Nope, that's the wrong way. Well, this not. Oh, there we go. And this works with most scientific calculators. It even works with a lot of the simple calculators. So in this case, we're going to start off by hitting 25 and just hit equals so that it has that in memory. And now we're going to go with the pattern. In this case, we go times 1.2. So I'll go times 1.2 equals. And that gives me the next number, 30. But now when I hit equals again, 36, every time I hit equals, it's going to multiply by 1.2. So I can use this to generate my pattern really quickly and easily. I just have to keep track of how many times I'm hitting equal. So give this a try. See if this works with your calculator. Following this, you should have gotten, this is your first 5 terms, 25, 30, 36, 43.2, 51.84. Again, if you're just trying to generate terms, that's a quick way that will often work with your calculator and works with most calculators. Now, if I want to find j sub 10, that's still not too bad to do. Let's bring up the calculator again. So 25 is my first term. Second term, third, second term, third, 4, 5, 6, 7, 8, 9, 10. So 128.99. I got to keep track of what I'm typing or how many times I hit equal. But 128.99 sounds reasonable. However, I don't want to do this 175 times. Nothing else besides the fact it's boring. I'm more apt to lose track of how many times I've hit enter. So we're going to use another way to do that. We're going to do this with spreadsheets. So we're going to use Sheets because Sheets is built in with Google and it's very handy to use. So I'm going to work through this example showing you how to use Sheets to do this. I'm going to put Sheets up on my screen. Oh, what in the world? I don't want that. My computer has a mind of its own. So I'm going to be taking off. My screen is going to be showing as I talk you through. We'll work through it on the spreadsheet. You'll have to come back later and relook at this slideshow to maybe help you with that. So first thing you're going to need to do is open up a sheet. So I'm going to open up here a new tab. And many ways you can do that. I'm just going to go under the waffle menu and bring up Sheets. Many of you are hopefully familiar with Sheets or doing this, but in case you aren't, we'll go through step by step. We'll open a blank one. And it's basically a grid here that we can work with. We call these cells. Each box you can type in something. That's called a cell, and we reference it by the column and the row. So this would be cell A1. You can kind of think back if you remember battleships. That's the same way. You use the same type of idea to identify places in battleships. But so this is cell A1. The sequence we're going to use is that f of 1 equals 500. F of n, I'll come back here. I'm off where I'm supposed to be. F of n is 0.6 times f of n minus 1 plus 3. So in the first column in this A1, we're just going to put our starting value. So I'll come to this spot here. And actually, let's make this a little bigger. Nope, it's not going to. Okay. There we go. 500. And hit enter. Now, the next part of your sequence, you have the first number, f of 1, the first number is 500. So the next one, to find the next number, you take 0.6 times the previous number plus 3 on this one. So for the previous number, I just want the number in this cell. So I'm going to start, and I'm going to type with an equal sign. And why that did that? Equal sign to tell it I want it to do a calculation. I'm not just giving it text or a number. I want it to do a calculation. My calculation is I'm going to put 0.6 times is shift 8 to get that star. You must use the times symbol when you're working with sheets. You can't just say 0.6 f the way we wrote in the formula. It will give an error. So you have to say 0.06 times, but now to give, I want it times this number, so I'm just going to click on this button on that cell. And you notice right in here it says A1. But it's orange. It's a different color because it's going to depend on, it's not necessarily always going to go to this cell. It's going to the one right above it. And we'll see that in a second. So we'll say A1. That's kind of like my U sub n minus 1. Or my f of n minus 1, sorry. Plus 3. So what we're saying is take 0.06 times the number in cell A1, which is the previous number, plus 3. It's kind of like with our formula, we said to find f of 2, we take, or f of 2, we take 0.6 times f of 1 plus 3. I hit enter, and it puts that same number in there. Okay, why is this easier? Because now I can select this cell and grab this little box here and drag it down. And you notice now this says 18.4. If I click on that cell, it says 0.6 times A2. So now I want A3. And it is using the cell right above it, A2. It copies that idea down with it. That's that recursion. I'm always, to find this number, I'm using the one right before it and adding 3. And I can just drag this down to find 10. I'll drag it down to 10. That's 12.46. If I want 175, I just carry it down, and I just keep going, and I keep going. Up, I went to 275. You notice after a while, this is a funky one. It settles down. We're getting 7, it gets down to 7.5 and stays there. Because this one, if you notice, it's neither arithmetic, because we're adding, but we're also multiplying. So something else is going on. It's not arithmetic. It's not geometric. It's a combination of both. And it's not going to go up forever or go down forever. So that's not something we're going to worry about too much. I just kind of want to show you how to use this spreadsheet to do this. So I have this instructions here on your slideshow, which you have a copy of. I want you to now go back and use this to find your values of j sub 10 and j sub 175. So take a second to do this on your own. Pause video if needed. I'll do these for you. I'll go 25 here. And I'll say this equals 1.2 times. And I could, since I know this is C1, I could click on that cell, or I can just type C1. And I'm not adding anything, so there we got 30. And now I can come back here and drag it down. So for 175, let me go over here so I can write. Clean off that stuff. If we look here at 175, we had 1.4788 E plus 15. This E means scientific notation. For those of you taking chemistry, definitely you really remember, you get thrown in with this big. You should have talked about that in your previous classes. This is basically 1.4788 times 10 to the 15th power. Or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's thousands, millions, billions, trillions, quadrillion. About 1.5 quadrillion. It's huge. But we can find that one there. If we needed 10, we go back to 10, and that was 128.99, which is what we calculated before by hitting equal on our calculator. So this is the idea of using spreadsheets to work with this. So here, do the Tower of Hanoi problem. Go back up here. So on this one, it wasn't arithmetic, it wasn't geometric. We're multiplying by 2 and adding 1. So we started 1, 3, 7, 15. See if you can figure out how to write a recursive formula for that first. Pause the video if you have to. Okay. Again, to start off, we're writing a recursive formula, so I can start off, and even though it's not geometric or arithmetic, I can always start with this. I know h of 1 was 1, so h of n, again, my pattern is multiply by 2 and then add 1. So I'm taking the previous number and I'm multiplying it by 2. And then I'm taking that answer and I'm adding 1 to it. So this would be my recursive formula written in function notation for the Towers of Hanoi. I want to find 25 disks. So again, I can come back to my spreadsheet. I'm going to show you another nice little trick with this. I'm going to start with 1. And then it's a formula, so equals 2 times the previous number plus 1. So now, since I'm starting this in a column right next to another column, instead of taking this and dragging it all the way down, I'm just going to double click on this. That's hard to do with stylus, so I'll do this with this one here. Oops, there we go. When you double click on it, it will automatically fill that down until it matches this one right next to it. So if you already have a column that's set as long as you want, you can just double click and you got it here. We got what? 33,554,431 moves to move a pile of 25 disks in the shortest number of moves. Yeah, right. Okay, so let's wrap this up. Main idea is it is so easy to do one of these recursive formulas and generate a table with a spreadsheet. So this is one tool that actually makes those worthwhile. The recursive formula is good for making a table. It's a pain to find some of those big ones, but you can make the computer do that. It takes no time at all once you know how to use that. And the big advantage is, like with the Tower of Hanoi, that pattern was pretty easy to see times 2 plus 1. But to find a pattern so that you could write an equation so that I just needed to plug in 25 into an equation and it automatically gives me the number, that's sometimes harder and sometimes we can't do that. So that's one of the reasons we like these recursive formulas. So again, I will post this slideshow for you. I will also post your homework. Have a great day.